Hello to everyone. In this video, we are learning about the atomic absorption spectroscopy. Atomic absorption spectroscopy is an analytical method based on the absorption of UV are visible by the free atoms in a gaseous state. The history of the atomic absorption spectroscopy. The first atomic absorption spectroscopy was built in the year of 1954 by the CSIRO, Commonwealth Scientific and Industrial Research Organization. Atomic spectroscopy is used to determine the concentration of elements in a sample. This method used for the qualitative and quantitative determination of more than 70 elements in an periodic table. A spectroscopic method which is very rapid and highly selective, and it is very convenient. The principle behind the atomic absorption spectroscopy. The technique uses basically the principle that free atoms generated in an atomizer can absorb the radiations of specific frequency. Atomic absorption spectroscopy quantifies the absorption of ground state atom in the gaseous state. The atom absorbs the UV or visible light and make the transitions to higher electronic energy level. The analyte concentration is determined from the amount of absorption. Concentration measurements are usually determined from the working curve after the instruments with the standard known concentration. Instrumentation of the atomic absorption spectroscopy. Majorly, there are 5 components in the instrumentation. First one is the radiation source, atomizer, monochromator, detector, and the computer. The first one is the radiation source. Halo cathode lamps are the most common source in the atomic absorption spectroscopy. It contains a tungsten anode and a halo cylindrical cathode. These are sealed in a glass tubes and filled with an inner glass. Each element has its own unique type of lamp which must be used for the analysis. After the radiation source, the second component is atomizer. Atomization is a separation of particles into individual molecules and breaking molecules into an atom. This is done by exposing an analyte into a high temperature in a flame or graphite furnace. An element to be analyzed need to be in an atomic state, so we are doing atomization. Atomizer, most commonly now we are using electrothermal or flames are used as an atomizer. The third component in a spectroscopy is the monochromator. It is very important part in an atomic spectroscopy. It is used to separate out all the thousands of lines. A monochromator is used to select the specific wavelength of light which is observed by the sample and to exclude other wavelength. The selection of specific light allows the determination of the selected elements in the presence. The fourth component is the detector. The light selected by the monochromator is directed onto a detector that is typically a photomultiplier, whose function is to convert the light signals into an electrical signal proportional to the light intensity. The processing of electrical signals is fulfilled by the signal amplifier. The signal could be displayed for the readout, for further fed into a data station for printout by the requested format. Is the computer. Here we are getting the complete information of an element in a sample. Next one is the calibration curve. Calibration curve is the important part in the atomic absorption spectroscopy. A calibration curve which is used to determine the unknown concentration of elements in a sample. The instrument is calibrated using a several solutions of unknown concentrations. The absorbance of each known solution is measured and then calibration curve of concentration versus absorbance is plotted. By this we are getting the concentration of unknown sample. And the last part is the application of the atomic absorption spectroscopy. It is very important to know the applications of a spectroscopic method. This spectroscopic methods used for the determination of a small amount of metals like lead, mercury, calcium and magnesium in a sample. Atomic absorption spectroscopy is mainly used in the metallurgy, alloys and the inorganic analysis, and also for the determination of calcium, magnesium, sodium, potassium in and blood serums, and also in the biochemical analysis, and it is also used in the field of environmental studies and for the determination of metallic elements in the food industry and the pharmaceutical industry. These are the major applications of the atomic absorption spectroscopy.